This is Steve, he's the president.
You look younger in person than you do.
Oh my God. Yeah, well, yeah, thank you.
So do you have a thumb drive or?
No, I have a
laptop
and an adapter.
Yeah.
So
You want to hook it up
later?
Is it HDMI?
That has, I can do HDMI, so I have, that's a USB.
Gotcha. Okay, perfect. Yeah. So if you want to open it up and get
Yeah,
PowerPoint.
it's all set.
Okay,
Yeah.
perfect. And then once we start, I'll switch it.
I'll just have to- You want me to just leave a thing here or?
Yeah, that's fine.
And I'll just start.
And then once, Rick's gonna introduce you.
Yeah.
So once he comes up, I'll just switch this HDMI over to yours.
Okay. Good to go. So I'll just leave that as a third.
And then I'm running Zoom on this one. So I'm gonna leave this, actually, I'll put it down here and then you can.
Sounds good. Just let me know what to do.
And then back to 30 again. Normal is low 30. Yeah, I just planted, I just did my seeding of the lawn, put all the seeds on there, just before. So hopefully.
Let me know.
Two cameras. No, that's Tuesday. Oh, I see. Yes, we're on for our board meeting. Whatever. That's good.
Good afternoon, everyone. Welcome to Beavercreek Rotary. I am your president, believe it or not, Stephen Brown. I'd like to thank our greeters, Matt DeSica, Pete Bales, Eric Marcus for being our ticket master, Mike Zwick, Pete Bales, Mark Weinstein for our great programs, Jim Gundo and Alex O'Hara for our website and YouTube, and Pete Landrum for being our Zoom guy. Thanks for getting that set up today, Pete. I'd like to invite Denny Jarvie up to do our invocation.
Would you please join me in prayer? Oh, Holy Creator, help us today to see our opening prayer as really a conversation. Believing you hear us and care about us, what we say. We pray for those people in Ukraine. Remind us that you are a perfect Father who listens carefully to his children and desires to do the very best for us. We thank you for this family of Rotarians to which we belong and ask that you bless us as we meet together today. Amen.
Amen. Thank you very much. Secretary's report, David Cusack.
All right, Joe Jenkins has a guest.
I have a guest. I brought my lovely wife, Amanda Jenkins.
Amanda, welcome.
Since our other commissioner has left, Rick Browse has a guest. He's our county administrator, Brandon Wilson. We have some guests with our guest speaker that I'm sure will be introduced at that time. We have attendance of 55.8%.
All right, thank you. Welcome David Fleming and James Gundel online. Sergeant at Arms, Don.
Good afternoon. By the way, if any of you have ever been a caregiver, I really have a lot of sympathy for you. My wife has had knee surgery on Monday and I've been taking care of her this week. And there's a lot of work to do there. So I really appreciate caregivers out there. As Denny said, please continue to pray for the people of Ukraine. It's a terrible situation over there. Today's weather is partly cloudy at 51. Tomorrow is going to be partly cloudy at 71. You know, I'm beginning to believe that Mother Nature is throwing temperatures out just like a Powerball. Just random numbers, throwing them out there. And one other quick thing, 2 years ago this week was a normal week, but we just didn't realize it was the last one we were going to have. Congratulations to Beavercreek High School swim team becoming state champions this past weekend in Canton. It's the first time since 1984 that a public school has been state champions in Ohio. And I think it was school down in Cincinnati has 31 of those, 34, 35. And it was really nice to beat them. So congratulations to them. Also, the hockey team finished with a great season. Even though they lost in the championship to Alter, they went 24-5-2 for the year and set a record for season wins and are only losing three seniors for next year. So we should have another good hockey team next year. And then if you all remember the song Convoy, Breaker Breaker 19, the Freedom Convoy is coming through Ohio. It actually spent the night in Ohio last night on its way to Washington, D.C. It's 30 miles long. They say they stop and have music and songs and eat at night. And I'm wondering how the guy in the front truck and the guy in the last truck get together. 30 miles, it's amazing. That's what it was Tuesday. Upcoming events tomorrow, Greene County Parks and Trails is offering their great pancake pickup. It's free. You just have to drive through. They're asking for donations though. And one of the things that's coming up that kind of reminds me of my youth is out here at the Nutter Center. The professional bull riders are going to be in town. I used to go to rodeos every weekend when I lived in South Dakota. And I don't see Brandon here, but this one's for him. There's a bird walk at the mound tomorrow. So the UD Flyers beat Richmond on Monday for a record of 21-9. They're number 4 in the A10 and play the number 1 team, Davidson, tomorrow. The Wright State men's basketball won their Horizon League tournament game last night over Oakland, 75-63 for a record of 19-13. And if I read the bracket right, they play Cleveland State on Monday in the semifinals. So good, I got something right. And Ohio State beat Michigan State last night. So I brought that in because our speaker here is from the Ohio State. As I said the first time I did this, I was not trained on how to do this, so I figure I get to do this the way I want to. So I came up with something that's a little bit off what you normally do, but these are rules to teach your son. So if you have a son or you have a son that has a son, these are some really good rules to follow. Never shake a man's hand sitting down. If you're set to meet at 3:30, be there at 3:25. The man at the barbecue grill is the closest thing to a king. In negotiation, never take the first offer. Go out of your way to open the door for others, especially elders and women. When entrusted with a secret, keep it. Write down your dreams. Return a borrowed car with a full tank of gas. Play with passion or don't play at all. Always protect your siblings. Don't let a wishbone grow where a backbone should be. If you need music on the beach, you're missing the point. Carry 2 handkerchiefs. One in your back pocket is for you. The one in your breast pocket is for her. You marry the girl, you marry the family. How true that is. Be like a duck, be like a duck. Remain calm on the surface and paddle like crazy underneath. Never be afraid to ask out the best looking girl in the room. Worst she can do is say no. Never turn down a breath mint. Try writing your own eulogy and never stop revising it. Eat lunch with the new kid. After writing an angry email, read it carefully and then delete it. Ask your mom to play. She won't let you win. Manners maketh the man. Stand up to bullies and protect those bullied. and hold your heroes to a higher standard. So that's just a few pointers for to give to sons that really could help them along the way. Today in history, the first Congress met and declared the Constitution in effect. There were 9 senators and 13 reps. In 1792, oranges were introduced to Hawaii. I had no idea about that. Washington's second inauguration as US president was the shortest speech, it was 133 words. I wish they could repeat that a few times. Inauguration day for all presidents from Washington to Franklin Delano Roosevelt was held on March 4th. During Roosevelt's term, they moved it to January 20th. The longest US presidential inauguration speech was William Henry Harrison. It was 8,443 words. Babe Ruth in 1927 became the highest paid player in Major League Baseball history when he signed a 3-year contract for $70,000 per season with the New York Yankees. Can't imagine how much that would be in today's dollars. In 1979, the 200th episode of All in the Family showed. I don't really think it would have lasted that long in today's world. In 1979, the US Voyager 1 photo reveals Jupiter's rings. We didn't know anything about it until then. And in 1997, the Brazil Senate allowed women to wear slacks. Now, I'm going along with some of the useless facts that I've quoted before. These are some odd laws that I came across. During the 6th century, it was customary to congratulate people who sneezed because it was thought that they were expelling evil from their bodies. During the Great Plague of Europe, the Pope passed a law to say, "God bless you" to one who sneezed. In Alabama, it's illegal to play dominoes on Sunday. In Minneapolis, double parkers can be put on a chain gang. In 1313, King Edward enacted a law that said you are forbidden from dying in Parliament. An old statute in Kentucky states that men who push their wives out of bed for inflicting their cold toes on them can be fined or jailed for a week. A 100-year-old law in Willowdale, Oregon makes it illegal to swear during sex. An odd law in Minnesota makes it illegal to hang male and female underwear on the same washing line. In Melbourne, Australia, it's illegal for men to parade in strapless dresses, but they're allowed to cross-dress with anything in sleeves. In Texas, 2 categories of men are exempt from peeping Tom charges: men over 50 and men with only one eye. An old law in Russia allows a police officer to beat a peeping Tom soundly. Oh, this is one excuse me for this one. A pregnant woman can urinate anywhere she wishes, including a policeman's helmet, according to a London local bylaw. In Vermont, women require their husband's permission to wear false teeth. In Tennessee, shooting any game other than whales from a moving automobile is against the law. And in Norman, Oklahoma, you could be sent to prison for making an ugly face at a dog. These are still on the books. There was a man watching TV and enjoying a beer. "Don't go," he yelled at the screen. "Don't enter that building. Walk away." "Oh, you stupid man." His wife called from the kitchen. "What on earth are you watching?" "Our wedding video." A little boy had been pawing over a stationer's stock of greeting cards for some time when a clerk asked, "Just what is it you're looking for? A birthday card, message to a friend, anniversary, or congratulations to your mom and dad?" The boy shook his head and answered, "No, you got anything that looks like a blank report card?" I just started a band called 999 Megabytes. We haven't done a gig yet. That was for Dave. My boss texted me and said, send me one of your funny jokes. I replied, I'm working at the moment. I'll send you one later. That's hilarious. Send me another one. I helped a friend hang a 75-inch TV he had purchased from a crackhead. When we turned it on, the menu showed KFC. It's not about how many times you fall, it's about how many times you get back up. The cop that was with me said, that's not how a sobriety test works. This is something that I've always wondered about. I don't watch this show, but the premise of The Bachelor, it's about a man dating multiple women at once, primarily watched by women who hate men who date multiple women at once. I waited in a restroom at a restaurant for 45 minutes the other day because the sign on the mirror said employees must wash hands. Nobody showed up. There's a bell or something to let them know. I was popular once, but a therapist took away all my imaginary friends. There's a fine line between a numerator and a denominator. Only a fraction of you will find that funny. I've found that in today's world, most people don't like holding hands, especially if you don't know them. Somebody asked me what to do with leftover bacon. I've never heard of that kind of bacon. Is it new? A friend was talking with their boss the other day, and the boss told him he just wanted to say how much he appreciated the hard work they did. My friend says, how about a raise? The boss said, we appreciate you in ways that cannot be measured in financial confirmation. I went to my doctor the other day and he asked if I was involved in any dangerous sports. I told him, well, sometimes I disagree with my wife. We'll end at that one. Fines for today. If you've ever been given a sobriety test, that's $1. If you've ever shot game from a car, that's $1. If you have ever watched The Bachelor, that's $1. If you still have imaginary friends, that's $1. If you've ever had a son, that's $1. I think I got most people on that. Stephen, back to you.
Thank you very much, Don. Here at Beavercreek Rotary, we always really appreciate our visitors. And I can tell you, we really appreciate you today because that is the cleanest sergeant at arms corps we've ever had. So give it up to Don. Thank you very much. If the visitors come back, you'll understand that joke. Real quickly, I did want to invite Rick up real quick. He did have some guests that came in. So if you want to, or you can just.
All of us. Are they all?
What are you doing when I enter?
All right, perfect. Happy Bucks. Who is happy today? Happy.
It's gonna cost you.
No, he can pay the $1.
Trying to save money.
No one's happy today?
I'll go, yeah.
All right.
So I've got $6, a little bit more for my fines, but that's for each boy that scored at state swimming. So state swimming was exciting. We had 6 swimmers. That's it. 6 swimmers, you only get to swim 2 of the 3 relays, and relays are worth 40 points. So we only had 2 relays. St. X had 9 swimmers, 3 relays, and a diver. And so even though we won by 4 points, the gap of difference between their diver and their extra relay was 50 points. So our boys did exceptionally well. So
Wow.
we're excited.
Huge congrats. Yeah, thanks for sharing that, Don. I didn't, that's kind of interesting. So not since 1984 has a public Ohio school won state. That's pretty amazing.
Stephen, I'm happy. I talked to a friend of mine over in Berchtesgaden, Germany this morning. He's doing well, his family is. He said so far they're not overrun by immigrants. And a little point of economic interest. He said gas is now €2 a liter. Multiply it up and it comes out pretty expensive gas.
Yeah. Beth?
I have an appreciation box for our Rotary Club for agreeing to sponsor the lunch for the Rotary Day of Service on April 30th. I'm the project coordinator for that day. Our district is going to be partnering with Rebuilding Things Together and working on the Children's Garden and the Boys and Girls Club in Inner City Dayton. So you should have received a link through the district, but if you're interested in volunteering that day, come see me and I'll pass on the information.
Thank you, Beth. Yep, so our club did the $500 sponsorship for the lunch that day. Obviously, it's a great program, so would love to see Rotarians there. But with us sponsoring as well, you know, definitely would love to see a good amount of us. As she mentioned, you should have got the email already for the volunteer link, but I'll resend that to you guys today as well. Anyone else? All right, let's do the,
We'll talk about next week's meeting.
after Bucks. Happy or drawing?
Winning number, last 4 digits, 9801.
All right. So we do a raffle every Friday. Half the proceeds go to our annual Christmas basket, which we go around Beavercreek giving gifts and food to needy families in Beavercreek. Pot grows. All right, perfect. We do have a couple of announcements. I have some paper here that I'm going to pass out, but Bob Wilda's memorial is coming up next week on Thursday. So I have information on that. I'll also send an email out as well, but it's next Thursday. Next week's meeting, it will be obviously the same time. It is going to be a little bit different because it's unique. We're very lucky to have them. We'll have Dr. Glenn Dewar and Mark Smith with Clark State coming here again. So usually they come or Cedarville, sorry. They usually come here before election, but they're coming to speak specifically about the Ukraine and Russian conflict. So again, the meeting is going to be the same. We're going to kind of hurry up this part of the meeting so they have more time. We made a Facebook event page for this. I would like to invite you guys to share that. We'd love to have as many people as we can. Like I said, it's such a great opportunity. So we appreciate the program directors for making that happen. So again, same time next Friday, but please invite anyone you would like. Other than that, I think that's it. So let's go ahead and invite Rick Prowlis up here to introduce our speakers.
Thank you, Steve. And boy, next week sounds exciting, very exciting, but I'll tell you, this week's going to be exciting too. I think you're all going to like it. First, I didn't get a chance to introduce one of my guests, Brandon Huddleston. He is our county engineer, sorry, our county administrator, and is doing a great job holding Dick and Tom and I up very nicely. Thank you for being here. And before I get to our guest speaker, I want to introduce a dear friend, William White. He's been with me for a long time, and I told him to not wear that silly hat, but he insisted on it. Hey, William, if you don't know, he played for Ohio State back in the 80s and played a few years. He beat all of them, yeah. A few years in professional ball, and he has ALS now. And he's still smiling and making a difference everywhere he goes, and he is wonderful, and I love him. And yeah, he's a wonderful. So if you guys get a chance afterwards, introduce yourself to him. Like I said, a wonderful guy, and he still eats well and drinks well and everything else well, right? Pretty much, yeah. But it was because of William that I met Dr. Kolb, who's our speaker today. And when I was in the General Assembly, unlike a lot of his colleagues that were speaking for ESPN and making tons of money doing color analysis, he wanted to help kids. So we got into a STEM program. I met him as the chair of higher ed, and we hit it off right away. And at that time, he could even compete with me in golf, and he was all over it. About what, 5 years ago, he got ALS, and that's how I met Dr. Cole. And we have been doing fundraisers and everything we can for that. William is still doing everything he can to help everyone out, but especially those afflicted with ALS. And Dr. Cole is from Ohio State, and he's amazing. When I heard him talk we did a jump at Green County, Skydive Green County, which is a great place. So let me give them a plug. And the guy was amazing. The stuff he talked about. I said, we got to get you a Rotary. And so let me tell you a little bit about Steve. He's associate professor in the Department of Neurology and Department of Biological Chemistry and Pharmacology. You're killing me, dude. At the Ohio State University Wexner Medical Center. He obtained his MD and PhD in neuroscience at the University of Texas Health Science Center in Houston. Completed neurology residency and postdoctoral fellow at the University of Penn. He is director of a lot of acronyms. The guy's just very smart. And he studies, this is it, focus upon molecular and cellular mechanisms of motor neuron diseases with the goal of developing therapies. Man. But come on up, Doc. He has got 2 daughters, Zoe and Lucy. He lives in Clintonville. In his spare time, which he doesn't have much of, he likes to do endurance sports like triathlons and cycling, and he enjoys gardening. He's an all-around great guy, but when he starts talking to you about this disease and what's going on with it, I think you'll be as fascinated as I. So, Doc, all yours, sir.
Thank you, Rick. I appreciate that. Very humbling, and my administrator assistant gives out those little words and stuff like that. So, but yeah, I spent some time in Texas. I actually do need to tell you I'm a Texas Longhorn. I went to undergrad there in Texas, but now I'm a Buckeye. I was actually born in Cincinnati. My dad went to UC, and so I was born in Cincinnati, raised as a small kid up in Mentor, outside Cleveland. So then I just went where the education was. So it was really kind of a blessing to come back to Ohio. And the reason I came back here was because of the science and the stuff that's going on at Ohio State. And just before I get going, I know we've got a time limit. I want to really wrap things up fast enough so that we can answer any kind of questions you guys have. Because if there's one thing that I want to try to accomplish, I'm not going to give you guys a big lecture or anything, but what is it that we're doing there at Ohio State for people like William and people who have ALS? A little bit about how kind of the sausage is made, because I think people don't understand how work in the lab to try to understand how a disease works translates into the development of therapies and how that is connected to how we care for people with ALS. Because there are plenty of ALS clinics out there that are wonderful that give good caregiving, and certainly we at Ohio State are doing that. But very few places are connected to the research like what we built here. And we really built this because of philanthropy, because of people who have trusted us enough with what it is that we're doing. And I'm very into the accountability piece, because I think that you don't want to donate money to something and then have it just go into a black box. William, like Rick said, one of the first things he did when I met him, I mean, he was almost cheering me up when we first met, because I'm pretty upbeat about things, but he wanted to know how he could help. I mean, and this was when he was, most of his life, he's way stronger than I am. and I couldn't even detect the weakness that he was saying that he was having at the beginning. So he has established his own fund. We have other funds. And so that's part of why I'm here, is to let you guys know, to be proud of your Buckeyes and the clinic and the research program that we're doing. Jennifer Lamb is here. She is one of my colleagues in the development, and she has really been so essential for helping William establish the fund and for the fundraising. And then I also have the great Sarah Heintzman, who's a nurse practitioner and clinical research manager. She is one of my partners in crime in the clinic. And so what I like to do is just sort of start with the headline. And what are the three things I'd like for you to kind of walk away from here? You know, a diagnosis like ALS is kind of like a terminal cancer diagnosis. You know, a lot of times it's like, well, shit, you know, that's it. You know, there's nothing that I can do about it. And, you know, back in the day, I think that was how some of these diagnoses were definitely handled, which, and even doctors would handle it, I think, poorly, you know, and kind of give up hope in that. We're in a different time, and a lot of that is because of the technologies that have been happening on the science side of things. We can do things we couldn't do before. And what are those things? So, you know, the three things that I want you to remember is that we can now study the disease in the lab in a way that we couldn't before. So to model the disease is what you can do, for example, in cancer. You know, in cancer sucks. You take a tumor out. The thing is, the tumor you can bring to the lab, put it in a dish, and those cells will keep dividing, because that's the problem with cancer. You follow me on that? And you can even take that tumor and put it on a mouse, and that mouse will get that cancer. So for a scientist who's trying to, you know, cure cancer, treat cancer, you try to kill those cells in the lab, and that's actually the beginning of a clinical trial pathway. It might be something that, you know, cured that mouse, so let's see if it can work. The problem with neurodegenerative diseases, which is what ALS is, and I'll just briefly talk about that, is that the opposite is happening than in cancer. So I like to think of like a maple tree growth, where you got like all those really green leaves coming out, you know, like around hopefully in a month or so. But those are all like your brain cells. But in a neurodegenerative disease, it's like in April or May that, like, you know, 10 out of those 100 trees, they start to turn brown and like it's fall, and those leaves fall out. It's selective. It's neuronally selective. If you've got Alzheimer's disease, that's a different part of your brain, right? If you got Parkinson's, that's another part of the brain. And so you have different symptoms. ALS is a disease of motor neurons, and those are the ones that essentially connect your brain to muscle. How is it? You know, I mean, I'm a nerd, so I get the giggles just doing that actually happens. And how is it that the brain makes that happen? We'll talk about that. So we can now model the disease like they can in cancer, because we know now how to turn a skin cell or a blood cell into a relevant cell type. And I'll just briefly talk about that. But that is research. That's what has, you know, we learned that in the lab in order to be able to study what's going on in the clinic. The other thing that has been happening, the second thing that I want you to remember, is that the genetics of ALS has been really exploding over the last 5 to 10 years. And OSU has really been leading the way in sort of offering genetic testing, understanding how to do the good genetic testing and counseling. We are now to a point where we understand that 10% of people, ALS runs in their family, for sure. 90% no. Of those 10%, we know pretty much all of the genes, and because of the technology, gets better and better as far as being able to read what's wrong. But we find that 15 to 20% of people who don't have a family history also have those genes, and that's new. That's something that we didn't know before. So who cares? Well, the thing is that not only does that help as far as knowing how things run in the family or what to expect, but it also lets us study and gets back to modeling disease. Now I can take like a mouse, or I can take a cell, and I can introduce that mutation if there's a new thing. And I can say, all right, what's broke now? And try to figure out what's going on from there. Does that make sense to everybody? So we got the two things: modeling the disease we couldn't do before, which we are now able to do, in the genetics of it. The third thing is this, and this happened here, research that was done here in Columbus, which a lot of people don't know about before, but we now know how to change genes. So if you got a broken gene, how do you fix it? How do you get to it? And now we have the technologies to be able to fix that gene in motor neurons safely. And we do that actually thanks to babies, because there's a disease called spinal muscular atrophy, which is also a motor neuron disease that killed babies. They used to die before they were 2 years of age, genetic disease. But the technologies developed to change gene expression in those babies was developed here in Ohio, and is now clinically available, and it works. It basically works. If you need to express something in a human safely, we can now do that. So it's a little bit science fiction stuff, but it is also something that is, if you genetically identify these babies, you treat them, they don't get sick. And that's what we're trying to do in ALS. That's what we're trying to pivot to. So that makes sense. Those are the three kind of things. And just stop me if I get excited and start talking too fast. Rick, you make sure to stop me if I get too crazy.
When you introduced yourself, you were going too fast for me, Doc.
Yeah, sorry. No, I can slow down.
You're doing
All
fine.
right, okay.
You're doing fine.
But I just get hyped about this stuff. So I already talked about this concept of neuronal selectivity. It's like, cancers, you have pancreatic cancer, lung cancer, colon cancer, they're all cancers. It's all the same problem, but in a different tissue. And the neuronal selectivity piece, oh, wait, I'm not doing it right here. Hold on. That's me.
Okay.
That's my bad.
We're good.
So yeah, thank you. But the neuronal selectivity piece is that this illustration is just PET scans, and just the bright spots are where cells are sick. And the different rows are different neurodegenerative diseases. And when I teach, I just show this to people to let them know that, that neurodegenerative diseases are related, just like cancers are related. It's just different parts of the brain. So motor neuron diseases affect the motor neuron. And they used to, back in the day, they'd call it in the nervous system the final common pathway, because you got all the thoughts going on. But in order to exert yourself, in order to come up here and speak, in order to breathe, in order to walk around, in order to write things, if you have an idea, the only way you can get it out there is to move muscles. Your brain has to move muscles. And that is why they call it the final common pathway, because ultimately your brain has to figure out how to move things in the right way in your throat and so forth, so that we can understand each other and communicate. And so just briefly, you've got your upper motor neurons, they're cells that are in your cortex. This is my brain cuts, like if you slice me like a salami down that way. And then they have wires that go all the way down the spinal cord and connect to a lower motor neuron. So you don't really have to know that, but upper and lower motor neurons are the two types of neurons that you have that are being lost in ALS. And then this is kind of the whole nut meat here. This is a muscle fiber. So when you cut up that steak, you see the nice muscle fibers in there. You've got that good old meat on you too. And each one of those muscle fibers is hooked up to a single motor neuron, which is kind of crazy. And those are the cells that die. I'm going to skip through these slides just for the sake of time, but I like to draw for the students how long these wires are that we're talking about. So yeah, my motor neurons in my spinal cord, but the wire that goes out to my finger, like LeBron James's finger, is like 20,000 times as long as the diameter of that cell. So it's basically a wire. We're basically talking about a wire in your body, and it also has to live for 100 years. You have to live your entire lifetime, because you don't make new. The ones you have right now that are helping you move around, that are helping your eyes move, that are helping you breathe right now, they were born when you were in utero, in your mom's belly. So it's crazy. I mean, I didn't get into this to be a doctor. I actually got into this when I was a kid on the science part. Like, that stuff is cool to me. But then as time went on, you start to realize that people, when things go wrong, that's when people need help. They're suffering. So motor neurons are cool cells. They are powerhouses. I don't have to go into this too much, but I did want to show you this one picture, which is this is actually a to scale picture of an actual motor neuron from a mouse. So mice, they're tiny. They have small limbs, but there's the cell body, and there's where it connects the muscle, and that's all the wire part. The yellow here is just, they labeled it with this yellow dye, so don't worry about that. That just shows where things are. This is where it connects the muscle. That's the nucleus, and that's the wire. But what's cool here is that the white part there, or whatever, blue, that's where mitochondria are. And if remember, mitochondria are like the little powerhouses, the energy powerhouses in all your cells. They're what gives you energy. And so these are cells. They're not only long and weird. They're not only they're not only connected to muscle, which all other neurons are connected to other neurons, but they are also always on and powerful, and always making lots of protein, lots of RNA. So why is it that just those trees are dying? Why is it that just those cells are dying in some of these, in people like William and people who have forms of ALS? That's the mystery. That's the kind of thing in the lab that we try to ask. What the hell's going on with that? So ALS is what used to be called Charcot's disease. Charcot was one of these old school guys. He had a microscope, because microscope was new technology then. And what he would do is he would watch people basically clinically as they got weak and died, and then cut them open. And he would stain the spinal cord. This is like a cross section of the spinal cord. And what he saw is, just take my word for it, this is a typical, here, this white part is scarring. It's on the lateral side of the spinal cord. And the patients died with having muscle atrophy. So he called it amyotrophic loss of muscle, lateral sclerosis, scarring on the side of the thing. And so that's why we have ALS. That's what ALS means. It's literally people who are losing muscle mass and they die because they have that selective loss. Those are where upper motor neurons are. And then they also lose the lower motor neurons that are in there. So I just want you guys to understand, kind of why we call it that. And it's kind of a complicated name. So here's the bad thing, that, I'm impotent as a clinician to stop the disease. I mean, you knew that. But that's what drives us in the lab. I'm very passionate about palliative care. I'm very passionate about end of life. I'm very passionate about the team care that we give to people who have these types of things. I think we've all had loss in our lives. I've suffered losses, which have definitely driven me towards this. But it is not satisfactory. And that is why we do the research. That's what the research piece is all about, is trying to fix that and to stop that, and to have some of the successes that we've had in spinal muscular atrophy, for example, or related motor neuron disease. So it's not as common as things like Alzheimer's. It's not as common as things like Parkinson's. It does affect people who are younger. It tends to affect men just a little bit more. Men who served in the armed forces are twice as likely to get ALS as other people. Generally, we don't know exactly why that is. And there are certainly some hypotheses. One is that people in the military tend to be healthy, robust men. And one of the things we see in clinic is that a lot of times athletes, people who don't have any other diseases, people who were, generally robust, they tend to be people who get ALS. And so what's with that? Could that be teaching us something about, if you're well sort of genetically endowed towards being gifted in that way, does that also put you at risk for having something like this? I mean, that's just a hypothesis that we try to think about. I want to make sure I give time for questions and everything. And it does have, of course, a meaningful cost, not as much as things like Alzheimer's. But unfortunately, the reason that it's not as much as Alzheimer's is that people don't live as long. And the bad news, is that on average, people from the time they're diagnosed live 2 to 4 years. People who, it's a large bell curve. So I have patients who I follow for well over 5, sometimes rarely 10 years. And it is something that is manageable, but we don't have any effective treatments for it. And that's obviously why I'm here. That's why we do what we do. And my job is to try to put myself out of business. So let's get back to those 3 things. I'm not going to give you a lecture on how we manage it in the multidisciplinary clinic. I mean, we have a very special group of people there. It's not just me. Once a diagnosis is made, I'm just an orchestra conductor. People who are smarter than me in their different domains, I'm going to talk to them about them at the end. But I'm not talking about the multidisciplinary care today. I just want to talk about what it is that we're doing that's so special on the research side. So let's talk back about the genetics then. So I did introduce the fact that 10% is familial, and we now know some of these genes. And let me just kind of go now to the modeling piece that we've done at Ohio State. So on the modeling piece, one of the first things I did when I came here was initiated a project where we now take skin biopsies, which is like a punch biopsy. I can bring that to the lab. And like I was talking before, we can trick those cells now to be converted, fibroblasts or skin cells, into these types of stem cells. Stem cells are cells that don't know what they want to be when they grow up. We're not talking about fetal stem cells. We're talking about stem cells that we induce from cells that have already differentiated. And so we're kind of tricking them. And this is technology that didn't exist, say, 5, 10 years ago. And now we can also, once we have it at that level, we can push it into a direction so that it's in a dish. It's not something that I can then give back to William and have him work. But it is something that I can now say, oh, that looks like a little motor neuron. It has gene expression patterns that are similar to that. What's different about people who have ALS compared to people who don't? And again, that's kind of getting it to the cell selectivity piece. I can't do that by studying skin cells. I can't do that by studying cells that I can't get to in you. I would hurt William if I tried to take out his neurons right now, but now we can model it. This work, we now have over 150 patients. We have published papers in science. You know, publishing peer-reviewed papers is sort of our product. It's sort of like what we do to disseminate knowledge and push things forward. And so that's a marker of the productivity and, you know, in sort of my business. You know, if we're able to do science at a rigorous level that where a lot of other smart people look at it and they try to tear it down, but it stands up to that scrutiny, then we're getting closer to the truth with a capital T on what is going on with that particular set of experiments. None of this would have happened without philanthropy. So all of those papers, the collaborations I have with the lab in Italy, you know, with at Nationwide Children's Hospital, other places like that, it just took a little bit of philanthropy actually to buy the skin biopsy needles, to, you know, buy the culture media, which is like Gatorade for cells, you know, in the thing. So I just want to get it was that piece that allowed us to have the cells, and then we could start talking with these other collaborators leading to stuff. So that's just an example of what we're doing at Ohio State that very few people do. And then the genetics piece, I wanted to show you what the actual genetic landscape is. This is time here, but you know, the number of genes is skyrocketing. And it's because our ability to read the genome, like if DNA was like a book, is improving. And so we are, you know, it's not just one gene that we had for almost 10 years. Now we have all these genes that are associated with ALS. And so that helps us to understand what's going on. This graph just shows the fact that most of the genes are in the familial forms. These are those sporadics that I was talking about before. This is even out of date by now. And so Ohio State has been kind of at the forefront of this. And one of my colleagues is a genetic counselor, but also a researcher who has been doing research on the genetics and genetic counseling in clinic. She's in clinic, she offers genetic testing on a clinical side, but she is also interested in access and making sure that people know, you know, that testing is available and how to interpret those results, because it's not always that straightforward. She's been extremely productive, and so OSU is now one of the leaders in genetic testing, and she's currently writing the genetic testing guidelines for the whole country. So I want you guys to be proud of your Buckeyes. You know, I mean, we're not like just seeing patients and handing out Riluzole and helping them with wheelchairs. We are fighting like hell and doing stuff that other programs that are more famous maybe than us are following. And I, you know, I'm pretty psyched about that. So and want you to be proud of us. Well, I want you to be proud of Buckeyes, not us personally. And so then the other thing that I talk about is this ability to safely alter gene expression. That's happening now. I can't tell you how crazy that is. These babies with SMA don't have enough of this one gene. And so the gene therapy, once that started to happen, I mean, you know, I was at one of these professional meetings of like pediatric neurologists, hundreds of them, you know, in this room, and you see these babies who genetically should be dead, walking around, pushing elevator buttons, and literally people were crying, you know, who'd spent their entire years, you know, telling moms that, you know, hospice for their baby or they do all this kind of stuff. I mean, it's a miracle. It's really hard to understate how dramatic that is. But it's also, from the scientific perspective, it's like, well, that means that we can do this safely. And what do we change? I don't know in ALS exactly what we change, but now we're doing it. And so this is that paper that showed the ALS stuff. This is a paper for an ALS gene which has just gone to clinical trial. And the first full clinical trial showed that it is safe, at least. And right now, there are clinical trials for a number of different genes. We are one of the few centers in the country doing this rare gene. FUS is the name of the gene, doesn't matter. But it is a gene that when you have it, you get ALS. And so we are, you know, we're being selected for these high profile kinds of technical thing. This requires injecting, a piece of RNA into your cerebral spinal fluid. I mean, it's high stakes kinds of stuff. But these people are definitely going to die from this, and it is an actual, shot on goal for them because we know what the genetic defect is. Since I have the time, I'm just going to throw out one of my metaphors. I mean, one of the things that I think in ALS we've been so unsuccessful in treating is because we didn't know what we were really shooting at. It's like taking a shotgun, shoving it into a dark barn, and turning your head away and shooting and hoping that you're going to hit something, right? And I think that ALS also is heterogeneous. It's the same clinical thing, but people have different genes that don't even seem to get there. So why do we even think that's one thing? Gene therapy, though, is more like you got a ranger with a sniper rifle who sees that particular gene, that's what's messed up. And now this is my thing that I know can correct that gene defect that's there. That's why I've built our clinic around this and have associated, on the front end with genetic testing and on the back end, with treatment. And my own lab is working on the middle ground of that, which is to design, to model those systems. So with philanthropy, what has that done for OSU? Well, my laboratory has taken one of those genes that I showed you, and we've created a mouse basically that has that same mutation, and it has a phenotype, meaning that it shows that it is impaired. Its motor neurons are impaired in being able to recover from nerve injury and aging and other things like that. And I have a NIH grant, which is, the NIH is what funds most of the basic science stuff that we do. And it's also just sort of a key metric of the kinds of success that we're having on the scientific perspective. We have a manuscript on this that's happening. These are two of my graduate students. So that, they are presenting. This was actually this week in Baltimore at Hopkins, where the ALS basic science thing conference was going. And this is their individual work in my lab from this. So what I want to tell you, this is not so much about KIT5A, which is a cool story in itself, but that this started with me being able to go to a fund like the one that William established and say, I have an idea. I think this is important. No one is looking at this, and it's going to cost me $10,000 to have this mouse made at this core facility at OSU. Then I'm going to get that mouse, and I'm going to need some money to do the initial studying of it. And once I do that, then I can apply for the big grants, because I sit on some of these study sections, and I've seen grants go down because it's like, well, you don't have the mouse yet. It's like, well, how am I supposed to get the mouse if I don't have money to do that? So that's why, if you look at Hopkins, you look at Mass General, you look at Emory, you look at Cedars-Sinai, all of those ALS clinics are heavily supported by love, by people like William who trust us, and by people like you who also are trusting us and want to push the envelope farther. This kind of science doesn't just happen because my chairman says, oh, Steve doesn't have to see patients today, he can go and do this thing. It is all about, being able to be free to do these things. Okay, I'm going to wrap things up here. Hopefully that is making sense. Is that making sense, Rick?
Right.
All right. All right. So here's the thing with my little Buckeye tree thing. So this is the multidisciplinary clinic. I mean, look at all the different people that one ALS patient, and I don't think I have all of them up there. I may not have updated this, lately. Is nutrition there? Yeah, I don't know. And then what's different about OSU is the roots, is all of these different departments and the scientists. There are plenty of PhD scientists. My laboratory is actually not in a clinical department, it's a basic department. There's no MDs near my department. When we talk about stuff, we talk about the science, we talk about that selectivity, we talk about those genes, we talk about that stuff. That's what they know. They don't know anything about the patient so much, but they're interested in that. What we do now is we connect it. That's what our program does, and that's what we call. I'm just going to skip through these, but that's what we call the translation. We translate things from the clinic into the labs in the clinic, going forward. And this is my block O finish, my dramatic block O finish. I don't have like much more than that. I don't have pom-poms. But here you got the clinic. This is the thing where the action is. This is where people who are dying of this disease come, and this is our interface. And in order to get them effective therapies, it takes that kind of investigator-initiated project that I talked about, whether that's a skin biopsy, whether that's doing genetic testing, whether that's having them volunteer to do some other study, that leads to being able to study the disease, what the hell's going on, that leads us then to the mouse work and then testing things in clinical trials, which is basically humans being guinea pigs in a clinical trial to, to, again, trusting us with that gift of letting us answer the question, does this work or does it not work? So that's the whole pipeline from the patient all the way back to the patient. And we're the only ones who do this in this region. This is what an academic center that goes. Yes, sir.
I'm sure it's different case by case, but typically how long does it take to go through a full circle?
It's a great question. And sometimes you can jump the line. So for example, so I guess there are a number of different steps here for the question. So when it used to take, if I had a drug that had already gone down here, I had a scientific rationale for why I think this is going to help people with ALS to get it to clinical trial. It used to take, maybe 3 or 4 years to get to the point where we know the answer. And then once we know the answer in a trial, then there used to be that regulatory delay that was going on. There's been a lot of improvement with the regulatory delay. On this piece. There's been a lot of improvement on the clinical trial, the speed of that. And we're a part of this platform trial, which is, we can talk about, after the meeting if you want, which is a design of trial that allows you to check a lot of different drugs in parallel. But I think that for some things it can take, an SMA, from the time that the gene was discovered in 1995 to the time that effective gene therapy was in the clinic and clinical trial was about 10 years later. That's SMA. And as I said, some of the genes that are important, we just discovered like maybe 5 years ago. So we're still in that phase. But I think that going from gene mutation to designing a way to correct that, to getting that's happening faster and faster. And this FUS trial, this FUS trial is happening. So that the future, I think, is going to be genetic testing. You get, you find out what your genetic test, you have your personalized sort of thing made, tested in the lab, and then within 6 months to a year, you're getting that to see if it fixes it. That's the dream, where we want to go to. So those are my 3 take-home points. And then I just want to finish with just a shout out to my team. It is not just one person, that someone gets to see. It's a team effort. We all talk together. But to have all these people in 1/2 day all by themselves, to do that is hard, to do. And then my lab, I'm very proud of the lab people that I have working very hard, graduate students, and I have undergrads also who work. So, one of the things about, being academics that is also nice is, you're bringing along the future. I'm not going to be here forever, so I want to make sure that we are getting more people involved in ALS and more people involved in these questions of selectivity. That's another thing that fellowships and other things help, is it'll help this talented student decide to go into this instead of cancer, for example. Not that cancer research is good. I don't mean it that way, but you hear what I'm saying? As a director, that's my mission. That's what I need to try. That's my business, my small business I'm trying to run. And then Sarah, of course, is the key part of the clinical research team, as well as being a clinician who sees patients with us. And but she's actually, I think, listened twice here. But these are the people who are actually doing the clinical translational stuff. These are the people in the lab who don't necessarily need patients. And then I want to just thank, we're just extremely grateful. I will come and go anywhere to tell people what we're doing with the money that they give, but it's not, it's really about making progress. It's about learning, and it's about getting things, to people. And so William, knows how grateful we are for his altruism, on that, his support. Unfortunately, Sonny Gordon, another OSU football player who was in the NFL, also has ALS. And so we have an unusual situation of 2 former Buckeyes and NFL players getting back to this robust talent that they even played in the same vacuum, at the same time. So there's something there. So anyway, with that, I hope that wasn't too fast or rapid fire. I hope I was intelligible. I also want to leave, I'm going to stick around. So if you guys have any questions after 1 o'clock, then please let me know. Lastly, I don't really have enough time, but Sarah, is here, and she and I can also talk about the ongoing clinical trials that are going. So if you guys know friends or connections or anyone like that who might be interested in coming to see us or is interested in research in participating, then please contact Sarah or me. Rick will have our contact information, and we can explain all those things. Okay. So thank you very much. I appreciate all.
Thank you very much. Per tradition, Rotary's big about literacy. So our club, every speaker, we donate a book. This is called STEM Lab, so pun intended. But we'll have you sign this, and this will go into the Greene County Library. Last but not least, again, next week, our meeting, please feel free to invite anyone that you would like to come. We're really excited to have Dr. Smith and Dr. Dewar here with Cedarville. So if that's it, then we'll go ahead and adjourn. Stand for the pledge. Doctor, would you like to lead us in the pledge?
Sorry?
Would lead us in the pledge? Yeah.
Do I stand?
You just started.
All right.
Our pledge of allegiance to the flag of the United States of America and to the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all.
Oh, thank you. I appreciate it. Thank you for joining us online.
Next week, we're gonna make sure that